Yes, we have three presentations. Sandy is going to present on beer and IPv6, which is thinks is a good makes beer more interesting for Babel. Dave is going to talk about something like that. I would imagine Aliyah might show up. Maybe not. Yeah. So okay. So is Dave here? I thought I might have recognized Dave. I don't see him. We'll get started in a minute or two. We have a sound thing available. I'm not sure how good the acoustics are.
Oh no, 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 no. Open the floodgates.
Yes. Hello. Okay. I guess we should go ahead here. This is the Babel Working Group. I'm Donald Eastlake from Huawei, one of the co-chairs.
Oh, I'm Russ White. I just sit up here because I make balance the other half of Donald.
Okay. So this is the note well, which I imagine most of you have seen before, that you should look at it if you didn't read it, if you haven't. By contributing to this working group or various other IETF activities, you're subject to the IETF's IPR disclosure obligations. It's a general request to review documents. We generally do fairly good about that in this working group, I think. And this is the proposed agenda. So we have Scribe to take notes. The question is, do we have somebody who be a Jabber Scribe for us? Yes, and if somebody on Jabberland wants to say something, you get to repeat it. Okay. Sounds good. Okay, if I go over the status and stuff. Okay, so I guess I'm going to talk a little bit about the status of things here. We have a bunch of working group drafts. There's a short applicability draft. It's currently expired. Hopefully get reactivated shortly. A information model draft, and the main draft currently we're working on is RFC 6126 bis. So the people who aren't aware, the idea of the working group is primarily moving the existing experimental Babel RFCs to standards track. So 6126 is the base protocol draft. This is a revision of that, which also incorporates extension mechanisms. And there's also a source-specific routing draft, which is a working group draft. We're sort of connected in some mysterious way with the HomeNet working group, which has a profile for use of Babel. And there's a few personal drafts out there. And on the bottom of the slide are the existing experimental RFCs. So we did okay on the first few milestones, but we're running a bit behind on the current ones. But hopefully we can make some progress on that. RFC 6126 bis has been in working group last call, and I believe it's announced to end tomorrow, which is when we were going to originally meet. So we can maybe talk about that when the status comes up during some of the presentations and stuff, but there was good support on the mailing list. So, is David here? But we have a microphone here. Oh, and there's also one there, I guess.
Other way, while David is getting ready, I thought I would point out that on the Network Collective, we've been doing a history of networking series of videocasts, and we had Julius on to talk about the history of Babel if anybody wants to go find it. It's kind of cool listening to them talk about where it came from and stuff.
Could you post a link to the mailing list, please? Thanks. All right. Good.
Oh, that's exciting. Awesome.
All right. Good afternoon, everyone. My name is David Skenazy, and I'm going to give a quick update on two of the Babel drafts. So our main one, 6126 bis, and the source-specific routing. So a lot of actually most of the text in the drafts is not mine. It's Julius's and Mathieu's. However, the slides are mine, so any mistakes are my fault. It's not theirs. All right. So Julius forwarded this to the list, but in case you haven't seen it, people are mentioning the Babel protocol in more and more places, probably because it's blazing fast. I'm not entirely sure how that fits, but I thought that was funny. All right. So kind of a quick overview of what we've been doing with 6126 bis from 6126. So the main goal is to go from experimental to standards track. And a lot of it is kind of clarifying the spec from, so we had a few people who did implementations from spec only who had feedback, myself included. And so we made all the pieces that those people found slightly confusing much clearer. Not that it was unclear before, the spec was really good. And we made two minor extensions to the encoding, And one is mandatory sub-TLVs, and the other is unicast to lows. So I'm going to give a quick detailed view of those. So Babel, specified in 6126 bis, mentioned the possibility of extension of sub-TLVs and extension, but didn't specify them. That was specified in a second RFC later. So one of the goals of 6126 bis is to unify those two documents. But also we realized that it would be cool to have a way to say that sub-TLVs are mandatory. What that means is if you receive a sub-TLV that you do not understand and that is mandatory, you drop the entire TLV. And the main use case for this is source-specific routing. So the initial version of source-specific routing in the first draft was had its own TLV. Yep, Tony P, question?
And Tony P. Juniper, and with the mandatory bit, you have proven already more intelligent than all the other IGPs combined in this forum.
Thank you. So for source-specific routing, now instead of having a TLV for source-specific routing and having like everything redefined in there, now it's just one sub-TLV that's marked as mandatory. And the reason it has to be mandatory is that if one router treats a source-specific update like a regular update, it could cause routing loops. However, with the mandatory bit, when it sees it, it just drops them, so everything's fine. And one of the other reasons is we also have another draft, which is TOS-specific routing. And if you use TLVs, you have to have a TLV for every combination, one for source-specific, one for TOS-specific, one for source and TOS. And so that it grows exponential really fast. So however, with mandatory sub-TLVs, you can stack as many as you want. So those are the main goals. And so the other one was unicast to lows. So there are two reasons for those. One is performance, because on a few link layer technologies, performance of multicast is really bad. The most common one is Wi-Fi, but also there are other link layer technologies that don't even support multicast. So in the original Babel spec, you could run every TLV on unicast or multicast however you wanted, with two exceptions. Acknowledgements need to be unicast, and hellos needed to be multicast. So now we've introduced a new concept of a unicast hello, and that allows you, once you've discovered another host, to run the entire protocol of a unicast. So that's not only more efficient, but it allows you to deploy security with unicast-only solutions such as DTLS or IPsec. As you may have guessed, those slight changes to the protocol don't have full backwards compatibility. However, one of the great things and one of the reasons we designed it this way is we really don't need a flag day. And that's really important because today there are active developments in Babel in production, and it's just not feasible to ask people to update all their routers on the same day. And from what Julius has told me, the plan for BabelD, which is the open source reference implementation, is to, so the code's already been written, is to push the change that understands mandatory bits and unicast hellos and make sure like it drops mandatory bits that it doesn't understand, and it can drop unicast hello as well, and only much later will it start sending them. And that allows you to, once you've upgraded all your routers to understand these, then you can start sending them. That's pretty cool. Then for those of you who have been paying even closer attention, I'm just going to quickly go through the changes between -03 and -04. Clearly the most important change is that I'm now a co-author. That's awesome. But apart from that, things that actually matter, we clarified a few things. There was some confusion on the list for some of the data structures. One of the really important things about Babel is that it only specifies the minimum of what needs to be specified to work really well. And a lot of...
Terry, can you hear me, Lorenzo?
That might be the wrong room. Who is this? We have someone in the ceiling. All right, never mind. Where was I? Yeah, and so, however, it still gives really good guidance for implementers because it's a really simple protocol to implement thanks to this. And part of this was to make sure that those data structures are clearly conceptual as guidance. They don't enforce anyway. You don't have to implement them this way. We also tweaked how we wanted to present unicast hellos to give more flexibility to the implementers and only give tips on methods that had actually been implemented and tested. Another slight change that was made was on hold time. One of the if you retract a prefix, you can't immediately start routing people to a larger prefix that encloses this because that could cause routing loops. So the initial Babel spec said you had to have a hold time, like on the order of 30 seconds. And however, Xuan, got a first name, came up with a better algorithm, which is that solves things, but there's a better property. If you actually have an acknowledgement from all of your neighbors to confirm that no one is going to route that prefix through you anymore, then you can release the hold time. So that allows much faster convergence in those scenarios. We also kind of discussed a bit more on sector requests. The discussion on buffering and jitter became more of a should, because jitter is not the only way to solve the all router synchronizing problem. We can advise for how to do routing router IDs, and we made a few things, give more clear guidance on sending requests. So in terms of next steps for this document, it's in pretty good shape. The changes that have been coming lately are pretty minor. And as Donald was saying, we went through last call, which ends tomorrow. And my take, Chairs can correct me, is that we had pretty good support. But the one item that I think needs to be cleared up before then is security. And I'm going to let Julius talk more about that in his talk, because I think we all agree that security is really important. We've put work into Babel to make it easier, such as unicast allows. And then the question that remains is, how do we specifically solve this, and in what document? Any questions on 6126 BIS before I go to source-specific routing? Nope. And so source-specific has just a minor update from 00 to 01. Mathieu added more introduction background explaining what this extension accomplishes. And specified wildcard requests, the -00 had several proposals that were up for discussion in the working group, and we reached consensus that basically wildcard requests are irregardless of all extensions. So a wildcard request is when you ask another router, it's blinking battery dead. Okay, and we're back. So yeah, wildcard requests are when you ask another router give it a view updates for everything it has. And the question was, if a router that understands some extensions sends a wildcard request to one that understands some extensions that cannot be necessarily the same set, what do you do? And the simplified answer is you just send everything you have. It makes all implementations simpler, maybe at the cost of some efficiency, but it's worth it. And that's about it. Any questions?
Testing. Another good microphone, too. We have two of them.
Great. So I guess you can keep it. I'll put this one there. All right. Well, thanks. Should we call Julius up?
So thanks for the presentation. I guess there weren't any questions on that. So next we go to okay. So I think you're on.
Hello?
Try talking.
Is the sound okay? Is the echo bearable?
Yes.
Okay, so hello, so I'm Julius Krobacek, and I'd like to say just a few words to start the discussion about Babel security. Next slide, please. Next slide. Yeah. So first I'd like to do a quick disclaimer. None of the ideas in this talk are mine. I'm just going to summarize things that have been explained to me by Marcus Stenberg, Denis Ovsienko, Toke Høyland-Jørgensen, David Skinazi, and Antonin Desimo, and in rough chronological order. And so if there's anything I say today that is wrong, I would like you to blame them, not me. On the other hand, if there's anything right, I will be glad to take credit. Next, please. Next, please.
There is a delay before you see it. I change it the instant you say yes, but then apparently it takes 2 or 3 seconds before you see it.
Okay, thank you. So the first thing I would like to stress is that Babel is a completely insecure protocol. So I've been stressing this on the mailing list. Don't think we should be saying that in the BIS RFC, in the core specification, that Babel is susceptible to such and such an attack. We should be extremely clear about the fact that without any additional security mechanism, Babel is susceptible to any sort of attack. So a Babel announce basically says, look, folks, I can route packets to that destination. And if you send a false update, if you spoof an update for IETF's prefix, then you can pass yourself for, say, the IETF website and redirect all traffic this time to IETF's website. Now, people think that you need to be central in the network so you can achieve a lower metric. That's not the case. If you cannot achieve a lower metric, you can do the attack by using a higher sec node, and there is something that just works in any routing protocol that uses the longest prefix semantics. Just do a longer prefix attack, and that will catch the traffic with no effort. Next, please. Now, okay. Now, the other thing to understand is that Babel is vulnerable to replay. So even if for some reason you cannot craft a false update, what you can do is capture a properly formatted, say, authentified update. Wait until it is legal to send it again. For technical reasons, it will take between a few minutes or a few hours. So you capture a lot of updates. And once you have a collection of updates, you just resend them. So what that means is that in order to be suitable for Babel, a security mechanism needs to be able to protect against replay. Next, please. Now, I would like here to fix this scope somewhat. There are 2 basic approaches. So very roughly speaking, there are 2 approaches to authentication. One is the end-to-end approach. You authentify an announcement at the source, and every receiver of the announcement will verify it. And the other is the hop-to-hop approach, when it's only the communication between neighbors that is authentified. And any properly authentified node can spoof any data. Now, end-to-end is the holy grail. It's something you would really want to be able to do. But in practice, it's extremely difficult. And so I think we should consider it as somewhat out of scope, which does mean we shouldn't be able to experiment with it. Next, please. So there has been quite a lot of work on security in Babel. And the user base of Babel is basically using 2 techniques. One is to use lower layer security. That could mean a physically secure Ethernet. Put a guy with a machine gun in front of every Ethernet socket. This can be radio links protected by some link layer protocols such as WPA2. And people have been running Babel over VPNs, most notably OpenVPN. And the other approach is RFC 7298, which is a fairly complete, I'm going to say a few words about it later, protocol for authentication at the application layer of Babel. Now, this has served us well. Users haven't been clamoring for other mechanisms. However, we are now aiming for a standards track. And so we need to define 1 or more security mechanisms and send a clear message to the user base saying, look, unless you have a good reason to do otherwise, this particular algorithm is the one you should be using for security. Next, please. So what are the approaches I know about for Babel? I think my analysis is that there are 2 serious contenders for being the one security algorithm. One is to use an HMAC approach together with a replay protection mechanism. So that's something similar to what OSPF does with RFCs 232857097474. And of course, there is Dennis's extension for Babel 7298. And the other approach that is being considered is to use DTLS, but DTLS is a unicast protocol. And so you need to run Babel over unicast. And there are other approaches, and I don't think there are some strong contenders right now, but I wouldn't like people to feel that they should be prevented from experimenting. There is lower layer security approaches. There is something similar to what is proposed for DTLS, but using IPsec. I think the person who suggested that is in the room. There is something that users have been clamoring for, and that might come as a surprise to some of you, plain text password. You know, you just dump a plain text password in every Babel packet, and if the passwords don't match, you drop it. It turns out that that solves quite a lot of problems, because most of the so-called security problems are actually misconfigurations. I'm not very keen on implementing that. I don't know how well it will go, and I have no doubts that there are others. Next, please. So the protocol that has been suggested quite a lot is due to Denis Ovshenko, who has designed and implemented and written it down in RFC 729. So it uses HMAC-based integrity and authentication. It has algorithm flexibility with 2 mandatory to implement algorithms. And it has a fairly refined scheme for replay protection that doesn't require persistent storage and doesn't require hardware clocks. And that's important because we want to be able to run Babel on embedded hardware. Now, 7298 is reasonably easy to implement. I haven't implemented it myself, but I've checked Dennis's implementation. However, it's a new security mechanism, and some people are a little bit nervous about having a new protocol stack. And so that's something that's absolutely great if you need to implement it from scratch. And as was explained in Prague, RFC 7298 has a rather subtle flaw that needs to be fixed. Next, please. So the other serious contender is DTLS with Babel. So the idea is to first switch Babel to be a unicast-only protocol. So you use multicast for discovery only, and all the rest of the protocol you run over unicast, duplicating announcements to every single neighbor. And then the unicast traffic is protected using DTLS. So DTLS is something you're not going to re-implement from scratch just for Babel. However, it's an already existing security mechanism. So that's a solution that's great if you already have a DTLS stack, and it's absolutely horrible if you need to re-implement it from scratch. And that the idea has been around for a long time. It was explained to me at different times by Marcus Stenberg, Toki Høyland, and David Skenazy. Next, please. So the original plan when I designed Babel back in 2010 was that any TLV could be sent over either unicast or multicast. And then there are 2 cases in which I didn't achieve that. Hellos can only be sent over multicast in RFC 6126. And ACKs can only be sent over unicast. ACKs are not used much in the protocol, but hellos are essential. And in 6126 bis, David and Toki have fixed part 1. Now, all Babel TLVs can be sent over unicast. So it's now possible to implement Babel over unicast only and only use multicast for discovery. So that means that you can use a unicast-only security mechanism. And it helps people, it pacifies people who have an irrational dislike of multicast. You know who you are. Next, please. So we've started working on that last summer together with Antonin Desimo. And he basically did all the boring bits, understanding how it needs to be done, what needs to be done, which DTLS library to use. And at that point, just as he was going to get to the interesting bits, he ran out of summer. And his work has been extremely useful. He identified some tricky points. First of all, we need to decide which TLVs we allow in multicast. So we are going to allow some unprotected TLVs because we need to do discovery over multicast, and DTLS cannot protect multicast. But that means that you have to specify exactly what do you drop and what do you allow in an unprotected packet. DTLS is client-server, Babel is peer-to-peer. So at some point, you have to match the impedance of the two. The DTLS libraries want to use connected sockets, and the Babel implementation uses the sample implementation of Babel uses unconnected sockets. And finally, the implementation is extremely inefficient if you start running everything over unicast. Next, please. So here are some preliminary answers to those questions. Which TLVs do you allow in unprotected packets? The simple solution is to say hello only, but in this case, you are allowing somebody to spoof hellos, which makes you vulnerable to DOS. Is that a problem? Is that not a problem? And do we want to solve it? It can be solved if this turns out to be something we don't want. DTLS is client-server, Babel is peer-to-peer. Well, what you can do is that after discovery, you decide that the guy with the smaller or the larger, it doesn't matter, router ID is the client and the other one is the server. There's an issue if you do out-of-band discovery. If discovery is not being done in the protocol, you might do discovery in some other way that doesn't give you the router ID. And at that point, you need some other mechanism. DTS libraries want connected sockets. We're using unconnected sockets. And here it's a little bit involved. I won't get into the details. It was explained to us by Marcus Stenberg. You need to run the library in memory and do all input-output yourself. And finally, well, we do unicast inefficiently in the current implementation because the current implementation does not use unicast much. The solution is to rework that. That's a simple matter of hacking, and the only problem is that there are only 24 hours per day. Next, please. So it's not my role to tell people what to work on, but just in order to start the discussion, I think that we should consider thinking about producing a revision of 7298 that fits well with 6126 bis and solves the security flaw of the current version. And ideally, we'd have at least 2 interoperable implementations. We definitely want to experiment with DTLS over unicast. I think we could finish that in a reasonably short amount of time once exam time is over. And ideally, again, we would have 2 interoperable implementations, and we would write down all the tricky details that have to be solved. I think that if we succeed in those 2 points, we might be able to publish both, but we need to pick one which is the recommended one. And of course, if people have other ideas and other plans, I very much want to hear about them. And those 2 plans should not prevent other people from experimenting. Thank you for your attention.
Okay. Do people have questions, comments?
David Skenazy, Apple. Thanks, Julius. We're getting some pretty bad echo from you. Where was I? Oh yeah, I just wanted to say that I personally really prefer DTLS to 7298 because of the flexibility it gives. One example is that you can bootstrap DTLS with symmetric keys or asymmetric keys or a PKI or whatever you want. So it really eases the trust model, which is a question that's still open in HomeNet right now, which is one of the use cases for Babel. And also, it gives better security than the HMAC extension, given that it encrypts everything as well, which is always a nice property. So that's kind of my take. Regarding the mandatory to implement topic, so maybe today's not the right time, but I would be mostly against that because if, say, you have a use case where you're running everything over IPsec, then you probably don't need this. But I think in a scenario where we want things to interoperate, like for the HomeNet profile, for example, we could make it mandatory, and that might be the right solution in my mind.
Are you hearing this stuff, Julius?
Yes, I
You're
hear.
muted. Okay,
So I
fine.
agree with everything that David said. Yeah.
So,
It's probably good for you to be muted because otherwise there's feedback.
This is Ted Lemon. So, Julius, one of the things that came up when we were talking about security on Wednesday is that you're using the multicast packets to check link quality, and that can be used as an attack if they aren't authenticated. Is that a true statement that you're using them for link
So
quality
currently,
detection?
over Wi-Fi, we are using multicast for link quality. What needs to be done once we switch everything to unicast is an open question. So that's the comment I made at the end about the DOS threat, which is all you can do with hellos is DOS the system. Is that a problem for us?
Right. Okay. So the other question is, have you looked at how things have changed in DTLS 1.3?
No, I haven't.
Okay. It might be worth investigating that, because I think there are some significant changes. And given that this is essentially new work, we might as well, if there's something in DTLS 1.3 that makes it better for us than DTLS 1.2, we might as well standardize on it.
Do you have anything concrete in mind here, or just generally speaking about the 1.3?
So unfortunately, my cache is blown. My recollection is when I looked over DTLS 1.3, it seemed like it would be better, but I don't really remember why that was. So I'd need to reinvestigate that.
Stephen Farrell, just two things. Yeah, I mean, I think given that this is a kind of a greenfield, using TLS 1.3 is probably going to be cleaner because you don't have any backwards compatibility issues, but DTLS implementations probably will. So you may get the backwards compatibility stuff when you go and try and pick up somebody's code to just do it. So it mightn't make that much difference. And then on the MTI thing, so there is a BCP that we have that says you need to have an MTI security answer for things like this. It does have a few get out of jail clauses, which might apply for things like HomeNet because they're small. So you'll probably get pushback. So I think if you can come up with something that people are happy enough with everybody having implemented, that would be better.
So the main point, just to answer Stephen, if that's okay.
Go ahead, George.
So the main point, I think it's premature to have this discussion right now. Right now, we need to have a solid proposal. We need to have a solid proposal and a solid implementation. Once we have a solid implementation and a solid proposal, then we can do all sorts of fun stuff like discussing MTI issues.
That makes sense.
David Skenazy, I agree as well. I wanted to respond to Ted's point. So I'm not a TLS expert, but one of the, as far as I know, the changes in DTLS 1.3 wouldn't really make big changes here. It's obviously a better protocol. However, also TLS and DTLS are designed for forwards and backwards compatibility. So whatever we come up with, I don't think the version of TLS is a big deal.
Ted Lemon again. So the thing that I remember, and I maybe maybe Stephen can tell me whether I'm completely all wet about this, is I seem to recall that DTLS 1.3 is a little bit easier to wrap into protocols that weren't really designed with DTLS 1.3 in mind, but that may be a completely wrong recollection because I haven't looked at it in a while.
Stephen Farrell again. I don't think so particularly, but I think, yeah, it certainly is worth looking at. And, you know, a profile of DTLS 1.3 for this might be smoother because it is better designed. However, again, I'd say that I imagine the likelihood here is that people won't write new DTLS implementations. They'll just pick one up. So it's going to do all the versions, and so you get all the crap.
Barbara Stark. So some of what I've heard about the 1.3 is that they did deprecate a whole lot of things as no longer being permitted to be used, and that certainly would be desirable. But it's my understanding that the protocol itself didn't vastly change, you know, all of the handshaking and all of the underlying mechanisms. So it might be useful to consider, but yeah. Anyway, thanks.
Okay. Are there further comments or questions? Dennis wanted to, but I believe he canceled himself from the queue, so it's not pending now.
Yeah, this is Barbara again. I do have a question. So, Julius, if I'm listening to you correctly, would that mean also that from the perspective of the HomeNet profile that you would suggest kind of holding off on that until we have a security recommendation here?
I would never suggest that. This profile, that's been 2 years. I would never suggest holding off on that. I want it to go out as soon as possible, Barbara.
Oh, okay. Dennis is going to type a question, I guess. Right. So, okay. Okay, let's move on then. Sandy, do you want to give your talk now? The
Okay. Okay, good afternoon. I'm Sunny Zhang from ZTE. This presentation is for beer in IPv6. We have co-author Tony. At first, let's see the motivation of this draft. Environments like HomeNet may not have hardware support for beer encapsulation, MPLS, or even support for special Ethernet type. It means that the process in beer working group, there is also MPLS encapsulation and Ethernet encapsulation for beer. But the Ethernet type for beer has not been allocated from IEEE. So there we have only, from now, until now, we have only the MPLS encapsulation functions for beer encapsulation. And native IPv6 encapsulation for beer hop-by-hop forwarding in pure IPv6 environments could allow to process beer in the slow path, like a control plane processor. Please feel free to the slow path, because we just mean the network, this kind of network pay more attention to service diversification than forwarding efficiency. So please feel free to this word. We not mean that your network is bad or your forwarding efficiency is too slow. No. just feel free for it. And the important reason for beer is the most important for this solution is beer is simply another next protocol for an IPv6 frame. You know that it will take a long time to achieve a Ethernet tab from IEEE, and so we think this function will explore the beer deploy environment. So let's see the solution. The solution is very simpler. The packet destination of IPv6 packet is set to the neighbor's link local address or one of the loopback interface address. Once the destination is set to the neighbor's loopback interface address, the address should be the same as the neighbor's BFR prefix. It's defined in beer architecture. And the source of the packet should be the BFIR's loopback interface address. And the address should also be the same as the BFIR's BFR prefix. BFIR means the ingress router of the domain, one domain. So it's also defined in beer architecture draft. And the TTL should be set to 1 because we think beer is a hop-by-hop forwarding function, and in order to avoid the loop or the other things, so we set the TTL set the TTL to 1. It will guarantee the beer forwarding correctly. And the next protocol should be defined to indicate the following beer packet. And the flow ID is the copy of entropy field in beer encapsulation. So it's very simple. The beer header is following the IPv6 header. The format is aligned with the beer MPLS encapsulation draft for a non-MPLS version. So we know that the S and TCBs have no significance here, and the BIFT ID is also the combination of subdomain set identifier bit string lengths. The remaining fields are unchanged with the beer MPLS encapsulation draft. So it's a simple function. Any questions?
Okay. I guess, thank you for the presentation. We have.
I
Julius.
just wanted to say, I've read the draft.
Go
I
ahead,
think
Julius.
it's some cool work, and it looks to me like it's eminently implementable.
Right. Right. It's easy to implement in the PC or in the small network or whatever. When you want to use it, you can implement in virtual machine, so you can verify the feasibility of this function. And later I will do this work.
There is one thing that is not entirely clear to me. So now we have multiple encapsulations for beer. So suppose you have a control protocol that is, so you have a control protocol that is announcing beer routes. Say it's Babel, for argument's sake. How does it know which encapsulation to use on a given link? How do I know that on this particular interface I'm going to use the IPv6 encapsulation rather than the native encapsulation?
I think I prefer the loopback interface address for the encapsulation. Of course, the link local address is due, but I still think the loopback it's unique that use the loopback interface address of neighbor. And this draft is for the data forwarding plane of the beer technology. And the previous slide is for the control plane of how to build the beer forwarding. So if we combine it, it works. We can do beer.
Okay. Perhaps I'll reformulate my question. You have defined beer extensions for advertising beer routes in OSPF and in Babel. Shouldn't those extensions? Qu'est-ce qui se passe?
Yeah.
Julius? Tony P. So yes, correct. This is architecturally unspecified. But if you think through that, if I announce two encapsulations, possible encapsulations, for the same combination of whatever we have there, subdomain SI, I can run per link a different encapsulation of my choosing.
Okay.
Okay, and I think that's where the architecture will go. That's unspecified currently. So with that, we'll be able very easily, we will be capable to very easily basically migrate from this kind of hack, right, which allows you very quick deployment, to something that supports the ether type and really
the
carries
routing
the proper
protocol
ether
be
frame.
signaling which encapsulation to use?
It's yes, it could, but it's a differentiation without distinction.
I'm not sure I understand, but perhaps we should take
You
it
know
offline.
this term, right? Okay. No, it basically means yes, you could, and it will behave in a specified way, but the ultimate outcome will be the same whether you do that or not, because it's a hop-by-hop forwarding paradigm, don't forget. So I know from both sides that the binding exists. In fact, I just need from the destination side to understand that the binding exists, and that I can use whatever encapsulation
But perhaps
I choose.
we should take that offline.
It doesn't matter, in fact. All right, we can take it offline.
Okay. I guess I'll leave that up. Yeah, that's the end of the agenda items. I have a couple items there to discuss on the list, including the security questions and any technical details of these things. So let's see. I guess I want to go down here. So anyway, I guess we'll see people on the list and at the next IETF meeting, perhaps in London in March. So thank you all for coming. I think that people mostly at this meeting did an excellent job of giving their name when they went to the microphone without even being nudged that much, which is pretty remarkable. And thanks to Barbara for volunteering to take notes and so forth. And that's it. Bye-bye.
I love the red button. It's very nuclear logic.
Right. It does have a
It's actually that's what it really is.
Oh, no. It's,
Yeah.
that's kind of very recent history of networking. And it's like, yeah, okay, yeah,
Well, we
IETF is
actually don't. We actually don't.
IETF.
We actually don't.
No.